Okay, so the first thing that you've got to do when you're trying to find the point of intersection is to make the x values equal, the y values equal. That's 9, 13 minus 3, plus phi, 1, 4 minus 2. And then you've got to solve for phi and for mu. And this is x, y, z, and that equals 2 minus 1, 1, plus mu, 2, 1, 1. So x equals 9 plus phi. That gives you the x values of the first one. And then x equals, it's 2. So it's going to be x equals 2 plus phi 2. So 2 plus 2 phi. Mu, because it's mu. Okay, so that means 9 plus phi equals 2 plus 2 mu. So that will give you, let's see if I bring that over to there and that to there. 2 mu minus phi equals 7. So that's one equation. So we've got 2 mu minus phi equals 7. Right, let's get the second one, the y values. So the y values are y equals 13 plus 4, 5, y minus 1. So y is minus 1 plus mu. So that means 13 plus 4 phi equals minus 1 plus mu. So the equation would be, bring that to there, that to there. Mu plus mu minus 4 phi equals 14. And then if I do the last one, the z minus 3. So you got z equals minus 3 minus 2 phi. And z equals 1 plus mu. So minus 3 minus 2 phi equals 1 plus mu. So mu plus 2 phi equals minus 4. Mu plus 2 phi equals minus 4. Okay, so when I go to solve that, I'm actually going to do it on these two, because if I subtract them, it's going to be quicker. I'll get minus 6 phi equals minus 18. So phi actually equals 3. And that's all I'm really after. Once I get one of them, then I'm able to actually get the point. Because if you just take one of these, so you take x, let's do the second one because we've got phi, x, y, z, and that equals 2 minus 1, 1 plus, oh, I got phi, so I've got to do the first one. So we've got phi, so I do x, y, z equals 9, 13 minus 3. Plus, I mean, you could do a second one and check it. That would be a way of checking. If you're confident in your working, then hopefully this should work out. So it's x, y, z, and that is going to equal 9 plus 3 times 1. Plus 3 times 4. My sign jump. No, wait a minute, that's a positive 18, therefore that is minus 3. That's the mistake here. That's minus 3, that's minus 3, that's minus, and then this will be 13 minus that, and then the y value would be minus 3 times minus 2. So that's x, y, z equals 9 minus 3 is 6, 13 minus 12 is 1, and minus 3 minus 6 is minus, oh, plus, minus 3 plus 6, which will be minus 3 plus 6, which will end up being 3. Okay. All right, now when we're trying to find the angle, I think that's pretty obvious in there, but cos theta equals a dot b on mod a mod b, and then you've just got to put the values in. So a dot b, you just multiply the x's, 1 times 2, and then 4 times 1, and then minus 2 times 1, and you just put it all over the square root of 1 minus 2 squared. And I think the working out there is pretty self-explanatory. And then you just go theta is cos the minus 1. Just remember, if it's a negative angle, you're talking obtuse, and if it's positive, you're talking an acute angle. And you should end up with 69.1 degrees. Okay, just looking at this, what vector equation of the line OA in this diagram? So you've got OA, which is here. So what is the vector equation of the line OA? So all that it would be is like, what is that point A represent? So if you look at here on the X value, you go across 1. The Y value, you go back -1, and then you go up. So we go up +1. So it's going to be 1 - 1 and 1. That will be the point A. Okay, so if you look at that, they've all got 1 - 1 and 1. So now all we need is the directional vector. Okay, so the directional vector OA. So if you went OA, A would be 1 and O is 0, 0, 0. So it's 1 - 0, -1 - 0, 1 - 0. So it's 1 - 1 and 1. That will be your directional vector. So your actual equation would be 1 - 1, 1. That's a point that lies on it. Plus k times 1 - 1, 1, which you see there is D. Okay, consider that quadrilateral diagonals AC and BC bisect at M. Use it, we want to prove that AB equals DC. AB, that's there, equals DC. Okay. Well, the funny thing is, if the diagonals bisect each other and it's a quadrilateral, then it's a parallelogram. So therefore the opposite sides are equal and parallel. So therefore the two vector equations would also be equal. But if we want to look at it in a different way, let's let AM equal P. AM equal P, so therefore MC must also be P. P and AM equals P. And then if you went MB, MB equals Q, so that means DM would also equal Q. So DM equals Q and MB equals Q. So therefore you've got AB, if you look at that, will equal AM plus MB, which equals P plus Q. And you could do the same for DC. DC equals the same, it will DM plus MC, which equals Q plus P. So therefore, these two things are equal. So what that's telling you is they are parallel and they have the same magnitude. So if you had to then say what type of quadrilateral, it's actually a parallelogram. If DC equals AD, that would make it a rhombus, or if the diagonals meet at right angles, that would also make it a rhombus. Okay, looking at this, two lines, that and that intersect at ABC, find ABC. So that's the intersection of the two lines. Okay, so if you want to get the intersection of the two lines, and the x values, you use 1 plus 4, 5, 1, will be the same as the other x value, which is -1 plus 5, 2 times 1. So 1 plus 4, 5, 1 equals -1 plus 5, 2. So that means that 4, 5, 1 minus 5, 2 equals -2 when you move them to the other side. Okay, so that's one equation. And then I'm going to do the y values. So y equals -3 minus 5, 5, 1. And y on the other point equals 6 plus 2, 5, 2. These have to be equal. So if you move this over, minus phi 1 minus 2 phi 2 equals 9. Okay. So looking at that, 4 phi 1 minus phi 2 equals minus 2, minus 5 phi 1 minus 2 phi 2 equals 9. So I'm going to use that to solve that. I could do the Z1 as well. The Z1, just set the Z1 up. It's not so important because I only need 2 unknowns to do it. So Z1 would be 3 plus 2 phi 1 will equal 7 plus 3 phi 2. So that means that 2 phi 1 minus 3 phi 2 equals 4. And that's your third equation. Okay, if you look at this, I'm going to now take this one and I'm going to multiply by 2. So you get 8 phi 1 minus 2 phi 2 equals minus 4. We'll call that 3. If you now subtract those, I'm just going to change the sign. That would be minus 13 phi 1 equals, they go out, you get 5. I'm just going to check that solution because that doesn't look very friendly. And where is it? Here. Right, so I'll go back up here. 13, I have made a mistake somewhere. Phi 1 is minus 1. Oh yeah, if you add those together, you actually get 13. Silly me. Okay, so phi 1 equals minus 1. So what they got there? Phi 1 equals minus 1. Yep, that's good. All right, so then to actually get the point of intersection, you don't have to find phi 2. All you need is one of the points. Because if I put it into the one with phi 1, so that means that x will equal, let's look at the point that has that. It's 1 minus 3, 3, plus phi 1, which is 4 minus 5 and 2. So you sort of sub it into one of the points. So it's 1 minus 3 and 3, minus 1, 4 minus 5 and 2. So x equals 1 minus 1 times 4, which is 4, which is minus 3. So it's 1 minus 4, and y is minus 3 plus 5, which is 2, and z is 3 minus 2, which is 1. So the actual point of intersection is minus 3, 2, and 1. So I'll just check that with the solutions. Minus 3, 2, and 1. Yes, it is indeed. Okay, so when you're looking at the second part, if you want to show that it's perpendicular, all that you have to do is show that r dot q, not r dot q, sorry, you just have to show, because they're equations of line, what you have to do is show that they're directional vectors. Their dot product is 0. So the directional vectors is this one and this one. So to show that, you take the 4 minus 5 and 2, and you dot product with the 1, 2, and 3, and you get 4 times 1 plus minus 5 times 2 plus 2 times 3, which is 4 minus 10 plus 6, which equals 0. So therefore the two lines are perpendicular. If you're looking at they were parallel, you only look at the directional vectors and you show that they are scalar multiples of each other. Okay, so this part's a little bit harder. To find the vector, the last part there, and then I'll just do that like, I'll just move it down so I've got a bit more room. Find a vector which is perpendicular to R and Q. Okay, let's add this on. Okay, so if we want something that is perpendicular to R and Q. All right, so what we need to do then is we know that, let's just, so what does it say? Find a vector that is perpendicular to R and Q. All right, so if it's going to be perpendicular to R and to Q, let's let its directional vector be Let's directional vector be A, B. I better not do A, B, and C because we used that before. D, E, and F, maybe. So what that means is that basically, if you've got D, E, and F, then D, E, F, when you dot that with 4 minus 5 and 2, you should get 0. So that'll form one equation. So 4D plus minus 5E plus 2F equals 0. That's one equation. And then if you get that again, D, E, F, and you dot that with the other directional vector, 1, 2, 3, you get D times 1 plus E times 2 plus 3F equals 0. So D plus 2E plus 3F equals 0. So we have that and that. Okay, so you go 4D minus 5E plus 2F equals 0, and D plus 2E plus 3F equals 0. So I'm going to get number 2 and multiply it by 2. 4D minus V plus the F equals 0. Actually, if I multiply it by 4, 4D plus 8E plus 12F equals 0. So I'm just going to subtract those two. So when you subtract it, sometimes it's easier just to do that. They'll cancel out, and minus 5 minus 8 will be minus 13e. 2 minus 12 is minus 10 equals 0, 10f. 13e equals 10f. Okay, so basically, when you're looking at this,